Okay, let's go and look at number 22. So, the rate at which people enter an auditorium for a rock concert is modeled by the function r, given by that stuff from time 0 to 2. R of t is measured in people per hour. No one is in the auditorium at time equals 0. When the door opens, the door closes at time t equals 2. Okay, so first off, as always, we should recognize that this right here represents a rate of change, right? It's the people per hour. It is a derivative of some function. Okay, from there, how many people enter the auditorium when the concert begins? So in other words, for part A, right, we want to know how many people enter. So as always, we're going to say, well, the number of people enter, well, that's going to equal however many people we start with plus the displacement. So in other words, it's going to be equal to, well, how many people did we start with? Well, we started with, in this case, 0 plus the displacement of our function. So 0 to 2 of r of t dt. Okay, and this, of course, is a calculator question. So I'm going to plug it into my calculator. And when I did, because I already did this ahead of time because there was calculator stuff, I got 980 people. Okay, let's move on to letter B. Find the time when the rate at which people enter the auditorium is a maximum. Justify your answer. So be careful. Find the time when the rate at which people enter the max is at a maximum. So we're trying to find the maximum for the rate of change of people entering the auditorium. So in this case, what I'm looking for is I want to know when the derivative of this highlighted piece, right? I want to know when that derivative is is equal to 0 because that's going to be my critical points, and I want to know where, because I'm using the derivative of that to determine the maximum. Because again, we're looking for the rate of change of a rate of change, right? Just to, again, one more time, I know I'm kind of belaboring this, but let's just make sure that makes sense. We're looking at when the rate at which people enter this auditorium is at a maximum. So I'm looking at the derivative of a derivative. Hopefully that makes sense. So first thing I'm going to do is I'm going to take r prime of t, right? I'm going to take the derivative of r and set it equal to 0. So when I do that, right now I'm going to go onto my graphing calculator, and I'm going to, so actually, let me do that. So first off, r prime of t equals, since my calculator doesn't do this, equals 2760t minus 2025 t squared. So I'm then going to take that and set that equal to 0. So I'm going to say this right here, I'm going to set that equal to 0. And then I'm going to use my graphing calculator to determine what that value is. So what I got was t equals either 1.363 or 1.362, depending whether you truncated or rounded. So that's our time, that's our critical value. But of course, we need to actually determine, is that a minimum or is that a maximum? So if you look at your graphing calculator, right, we can see that to the left of that value, right, when we look at the well, to the left of that value, from the left of r, it's positive, r prime. Sorry, let's try that one more time. To the left of t equals 1.363, r prime is positive, and to the right it is negative. Okay, so let's put that, which means we have a maximum at the t value. So let's go put that into coherent English, since apparently I'm struggling on writing coherently or speaking coherently. So let's see, the rate of change in the people per hour entering the auditorium. Let's see if I can spell that. Auditorium, maybe? oh good, is at a maximum when t equals 1.362. Again, 1.362. You can use either of those two numbers that I had before, because at that point, r prime changes from positive to negative. Boom. Boom. Okay, let's keep on going. Letter C. Letter C. Whew. Oh, too long, didn't read. TLDR, right? Okay, let's see. The total wait time for all the people in the auditorium is found by adding the time each person waits, starting at the time the person enters the auditorium and ending when the concert begins. The function W models the wait time for all the people who enter the auditorium before time T. The derivative of W is given by that stuff. Find W2 minus W1, so we're looking kind of at the displacement from time 1 to 2. The total wait time for those who enter the auditorium from time after time 1. Okay, whew. Kind of long, but I think I got it. I know I got it because I did ahead of time. So let's see what we got here. Let's see what we got. So first off, we were told, I'm just going to kind of reiterate this, we were told that W prime of t equals this stuff. So what I want to do is I want to go and find, right, I want to go find this. No, from 1 to 2. And I think you would agree that's going to be the definite integral of this. Okay? dt. So this is a calculator question, right? So I'm going to be plugging into my calculator just to make sure that we are clear. Into my calculator, I'm going to be plugging this. And what was R of t? What is R of t? I forgot. It is 1380t squared. 1380t squared minus 675 t cubed dt. Okay, let's just double check one more time. 1380675. Yep, okay, so that's going to be plugging into my calculator. This is absolutely a calculator type question. So I get, when I do that, I get 775 divided by 2 hours. Okay? So let's move on to number 3, D, letter D. Let's grab letter D so I can look at it. Okay. Let's get rid of some of this. This is not needed. What do we got? On average, how long does a person wait in the auditorium for the concert to begin? Consider all the people who enter. So let's see the auditorium and use the model for the total wait time in part C. So let's kind of backtrack for just a second. Let's go back to C really quickly. So this right here, this function right here that they're giving us, W of t that they told us, W models the total wait time for all the people. So in other words, this thing right here is, that's the rate of change, obviously, but the antiderivative of that would represent the total wait time for all the people entering the auditorium. So what are we going to do? In order to find the average wait time for a single person, I'm going to take the total wait time for all the people and divide it by the number of people, which we actually already know the number of people. We found that in part A. So let's go and do that. So again, one more time, what I'm going to do is I'm going to take the total number of people who enter the auditorium from 0 to 2. So in other words, whoops, in finger paints, I'm going to go from 0 to 2 of W prime of t, because that's what they gave us, right? That's going to give me the total wait time for the people from time 0 to 2, and then I'm going to divide that by the total number of people, which was 980. Okay? So when you do that, you get t equals either 0.775 or t equals 0.776. Okay, so again, one more time just to reiterate that. What did we do? Well, they told us that the function w represents the total wait time for people entering the auditorium, for all the people. So I said, okay, this is how many, so from 0 to 2, this was how long, I don't remember what it is because I did it on my calculator. So this is how long the total number of people, all 980 people, waited, right? They took this amount of time, but I wanted to find the average for one person, so I had to take all those and divide it by the number of people, which was 980. Okay, that is number 22. That's all I got for you on this one. Again, as always, if you have questions on it, please feel free to email me or ask them on Zoom on the day that we meet. As always, please make sure that you do not like, comment, and subscribe, and I will talk to you, or subscribe, right? And I will talk to you next time.